This is the makeup video for the evidence of a chemical reaction lab. You'll need this paper to complete this lab. If you don't have this paper right now, get it before you continue this video. I'm going to try to do this video in less than 10 minutes. It's pretty straightforward. On the evidence of a chemical reaction lab, there are 4 experiments. I'll go through each one. Any other definitions on the lab, you will need to look up for yourself. For example, in the pre-lab, define a chemical reaction or chemical change. Look those up for yourself. Very easy to find on Google, Wikipedia. List 4 types of evidence that a chemical reaction has occurred. Again, you can look those up very easily for yourself. So we are starting with experiment number 1, copper sulfate solution and iron metal. It says, carefully dip iron fibers in the beaker with the copper sulfate. These are our iron fibers right here. This is plain, simple steel wool. This is our copper sulfate, blue, bright blue solution. This is going to be a pretty obvious change. We'll hold our sulfate right here, so you can see. Doesn't take very long. Swirling the solution around before you can start to see the reaction. A little shake of that, you can see a very distinct change between the iron that went into the copper sulfate and the iron that did not. All right, that's experiment number 1. Now, on your page, follow the directions there. Did a chemical change take place in this experiment? How do you know? What is your evidence? Draw a picture of the before and after. In this one, you're going to need to use color. Balance the chemical equation below. If you need support on that, there are quite a few good YouTube videos and explanations on how to balance chemical equations. We are on to the next experiment. Experiment number 2, potassium iodide and lead nitrate. These are our potassium iodide and lead nitrate. Right there. Potassium iodide is Ki, lead nitrate is PbNO3(2). We're going to use a beaker for this, as our instructions say. It says use the dropper bottle to add about 5 milliliters of potassium iodide solution into a small test tube. This is our test tube. This is our potassium iodide. It's going to require about 5 beakers full to get 5 milliliters. We estimate 5 milliliters by saying about the width of a pinky in the bottom of the test tube. Here's number 4. That looks like plenty. So again, width of a pinky, bottom of the test tube, that's easily 5 milliliters. We're going to take our lead nitrate. All we need of this is 1 drop. And make sure you can see it. Adding the drop now. There's another drop. You can see that very interesting chemical change. If I give it a swirl, it'll be complete. There we go. We're now on to experiment number 3. Magnesium and hydrochloric acid. Magnesium, in this case, is in its metallic form. These are small little pieces of magnesium metal right there. We're going to take one of those and put it in a beaker with 5 milliliters of hydrochloric acid. Now I know this beaker for our hydrochloric acid, or this dropper I mean, has been leaking a little bit, so I'm just going to add it straight from the jar. Again, about a pinky's worth in the bottom. That's about all we need. And a couple pieces of our magnesium. Going to drop it in right now. There we go. And you can see that reaction taking place immediately. If I hold my microphone right up to it, you can hear it quite well as well. You can see vapor collecting on the side of the jar. You can see bubbles happening right down there. Give it a shake, makes the reaction more aggressive. There we go. That reaction will continue until all of the magnesium is gone. Same process as before. Answer the questions, draw before and after, balance the chemical equations. Same was true for number 2 as well. Experiment number 4, calcium chloride in water. Now for this one, we're going to have to add some water and make sure our temperature is correct. So we got to take some time to let the temperature get up there in our water. So we need to let this thermometer sit for a few minutes. Make sure they're the same temperature. Fortunately, before I started this, I verified these temperatures. So this water is the same temperature as the room was that the thermometer was in. So our temperature right here is, as you can see, 21 degrees Celsius. You're going to want to mark that down, 21 degrees Celsius. That is the starting temperature for our water. Now, it says to take 3 good-sized scoops of this, our calcium chloride. I'm going to remove that, dump these in. This process can get a little messy, so I'm going to use my beaker stand. There we go. Now, the directions say to give the calcium chloride and water mixture a stir with the thermometer, and then read our thermometer, see if there was a reaction. You can see the red line of our thermometer going up, up, up. It's already at about 39 degrees. If I give this another little shake, might be able to get it to go up a little farther. If I feel the bottom of this, it's pretty hot to the touch, pretty warm to the touch. If I look at my thermometer now, we're at about 40 degrees. 40 degrees. So we went from 21 degrees starting temperature to 40 degrees. Again, do a drawing before and after. In this drawing, though, it says, draw a picture of the water molecules, imagine them magnified in the test tube before the reaction, then after the reaction. So that means you're going to draw individual little particles of water. Each particle can be represented by just a small ball or sphere, a small circle in your beaker. And then you draw tails. It says, remember, longer tails means faster moving particles. Make note of any changes that recur in your drawing. So short tails means slow particles. Fast tails, or long tails, means fast particles. Don't forget to balance the equation. Small note here, in the equation you see Ca plus 2 and Cl minus 1. The plus 2 and minus 1 simply indicate that they are ions. When they were put into water and they broke down into solution, the calcium and the chlorine became ions. That doesn't affect the balancing of it. So when you're balancing it, just think of it as Ca and Cl. That's the end of this lab. So make sure you have every question and every drawing done. Turn it in. You'll be all set. Thanks a lot. Bye.